Okay, so let us solve this problem. The problem states that you have been given a plot which is like this one piece, another piece is like this plot is v versus time, velocity is on the y-axis, time is on the x-axis. And you see, if I were you, I will split this plot into two pieces. Number one is positive slope, number two is the negative slope. So the slope for this one is 30, correct? And the slope for the other one is negative 15. So it is asking you to plot another graph, a versus time. So what I'm gonna do, I'm gonna show you how would you do that. Like acceleration, this is the time dependence. Look, you will take the first piece. I will say just in my 1 sub 1 means like first piece, time derivative of 30t, which is equal to 30. Agreed? So it's a straight line up until what time? Do you know what time it is straight line? 5 seconds. Good job. It is up until, this is time in seconds, and this is acceleration y-axis. So I will do the same process for the second piece of the plot. So the acceleration is the time derivative of the other expression, which is negative 15t plus 225. So if you do the time derivative for the second part, what do you guys get? Negative 15 meters per second square, meters per second square. So it's a negative 15. I will draw it a little bit below. So I will draw a bold line from here up until, look, 15 seconds. So up until 15 seconds. So you see my point. So this is our plot for acceleration versus time. So now the second part says find out the plot position versus time. And you just learned, look, you just learned that if you want to go from position to so velocity position, you have to do the integration. So what I'm gonna do here velocity, it is equal, in the first portion it is equal to 30 times t. Let me make sure it is 30 times t. So now I'm interested in position versus time. So look over here, how do you go from velocity? Because how do you go from velocity to position? We know that this is the basic formula, and this is a position v dt. So you have to integrate it from 0 to s, any position, and from 0 to, the first piece goes from 0 to 5 seconds, correct? So I'm going to do the lower limit at 0, and 5 is the upper limit, and v1. Let's do the first piece, which is v sub 1, 30 times t, and integral. 30 is outside the integral sign because of the constant, and dt. Can you help your professor? What is t? Integral for that. Yes, t square over 2. Good job. So I'm going to apply the limits of 0. Sorry, this is 0. So what do you get? Do you get 375? Please open your calculators and help your professor for finding the final position, which is, let me know if it is 375, right? Negative 15t. Open your calculators and make sure you get the same answer from 5 to 50. This is for the second piece. From 5 to 15, you have to integrate it, this expression, 5 to ds2. I would say sub 2 means like the second piece, okay? It's just for our convenience, it doesn't matter. Like 375 or the ending point or the first piece. Do you get 375? One student says verify, this is 375. So the next piece we do not know. So the left hand side here, it is s minus, like if you do the integral, this is s upper limit 375, the lower limit, And over here we will do the two terms, integration of two terms. The first term is negative 15 t square over 2. Agreed? So please share your reflections whether you understand or not. So this is our first term integration. I'm going to apply the integration limits here. 15, 5, and plus 225 is outside the parentheses, and dt, the integral of dt is t, and 15 and 5. And if you do the math here, you should get negative 7.5 t square plus 225. This is the expression, and so on. So make sure you get this 15 and 5, and you find the expression, and finally you will plot it, because the position versus time. The first piece is like a parabolic function, like 15t square, correct? This is our first piece. 15, it's just a rough parabola. It is 15t square, and the other one is kind of like something like, it's also parabolic function, so you will drew it like this.